All right, so with example 4 continued, recognize that people that do this make tons of money because of this exact reason. We have the Macron plant that charges $600 for what it produces in one run, and Jonesboro charges $1,000 for what is produced in one run. How many production runs at each company, at each plant? How many production runs should each plant produce to keep costs as low as possible while still filling the order? So in each of these three instances over here, everyone, the order gets filled. All of these are going to have a different cost associated with them. We are doing business. We want to find the cheapest cost possible. So again, for Macron, costs are equal to $600 for every run. So 600x at Jonesboro. Costs are equal to $1,000. Every one, which for Jonesboro is y. And so again, remember we associated x with Macron or Macon and y with Jonesboro. So our total cost function here, everyone, is going to be 600x. So $600 every hour that Macon runs, plus 1,000y. So $1,000 every time Jonesboro runs. And so what we are going to need to do, as we have in the past, is we are going to test each of these options in Wolfram and come up with a recommendation for this company to minimize their costs or keep costs as low as possible while still getting the job done and filling the order. So we have 60 times 0 plus 1,000 times 180 as one option. So 0 hours at Macon, 180 hours at Jonesboro. We have a bit of a split here, 40 hours at Macon plus 60 hours at Jonesboro. And another split, we have 80 hours at Macon and 20 hours at Jonesboro. And lastly, we have 130 hours as an option at Macon with 0 hours at Jonesboro. And so in the harsh reality is that everybody has jobs. There's somebody that has a job at these plants, and in some cases it is cheaper just to shut the plant down and not even run it. We're going to be advising, that's going to be our job, is to figure out how to advise this company. Do you completely shut a plant down? Do you keep it going? What do you do to be the most cost effective to fill this order? Testing option 1, everyone, I've got in Wolfram what we had there. We end up with a cost of $180,000. Let's see if we can beat that. So we've got 600 times 40 plus 1,000 times 60 for our next example, $84,000. G, let's think for a second. If I'm in business and I'm trying to have my costs down and you come to me with this, you just saved me nearly $100,000. Guess what? I'm going to hire you again. This math is worth learning, even though it's kind of a pain. All right, next, everyone, we have 600 times 80 plus 1,000 times 20 and 68,000. That's a drop of nearly $20,000 again. So again, the difference between the first option, which is just running the Jonesboro plant, and the second option, which is running 80 hours at Macon and 20 hours at Jonesboro, to do the exact same job, there is about a $112,000 difference in the cost. That's a big deal. Lastly, everyone, we have 60 times 130 and 1,000 times 0. Which brings us to what is not going to be the cheapest option. Still comes in second on our list. And so to keep the cost as low as possible, the answer here is very simple, everyone. Run the Macon plant for 80 hours and run Jonesboro plant for 20 hours. Doing this as compared to running the Jonesboro plant to completely fill the job gets the exact same job done for $112,000 less. That's pretty sick right there.